This is the screencast for section 2.5, example 6, factoring a polynomial. So in these instructions, it's going to ask us for a product of linear and irreducible quadratic factors. So the question is, what does irreducible quadratic factors mean? Well, it means it's going to look like x squared plus a number, or even x squared minus a number. Basically, if you, it would be x squared plus a number. If you factor that any further, you'll have imaginary numbers. So we don't want any i's in there, which will cause us to have some x squareds. Not all of our factors will be linear. So I took the liberty to graph f of x on my own and find the 3 real zeros that occur there. 2/3 was one that I can easily pass through synthetic division. So since 2/3 is a rational zero, gave me remainder 0, I can use 3x minus 2 as a factor. Remember, we don't use fractions in our factors. So I write this as 3x minus 2 because if I plug in 2/3, it would make that quantity 0. Then the rest of this would be single x squared cubed, 3x to the 4th plus 6x squared minus 24. So I've got x minus 2/3, there we go, as a factor because 2/3 is a rational zero, got a remainder of 0 when I did synthetic division, which then leaves me with 3x to the 4th plus x squared minus 24. So now I have a greatest common factor in here of 3. So I'm going to take 3 out of that and have x to the 4th plus 2x squared minus 8. Now this 3 will help me with my first term here because I don't want to leave 2/3 as 2/3. I would rather that be 3x minus 2. We can't have fractions in the factors. Now I know that x to the 4th plus 2x squared minus 8 factors, this is just 1 degree, or excuse me, this is like a quadratic function, just now x to the 4th, x squared and nothing. So this can factor into x squared plus 4 times x squared minus 2. Well, I know that x squared minus 2 can be a difference of squares. So I'm going to shrink that down a little bit. So I have 3x minus 2 times, here's one of my irreducible quadratic factors, x squared plus 4. And then I have x minus the square root of 2 times x plus the square root of 2. So here is a product of linear and irreducible quadratic factors, all with real coefficients. If I factored x squared plus 4, if I set that equal to 0 and find out what the zeros were, that would be positive 2i and negative 2i. So I can't use those in my factor. This is my final answer. The now try problem for example 6 is number 37. So again, I graph number 37 to see where I can start with factoring, and I see that positive 2 is a 0, so I'm going to put positive 2 through synthetic division to see how I can factor out the rest of the problem. So since 2 is a 0, I broke down the original function into x minus 2, its factor, and then the rest was x squared plus x plus 1. Now, I know from the graph that 2 is going to be the only real 0. I guess 2 could happen as a 0 3 times, but I know that that function would be, this would break down into x minus 2 quantity squared, and it clearly does not. Now if I did quadratic formula and solved for what would make this trinomial 0, I would see that there's imaginaries in there, which lines up with what my graph says. 2 should be the only real 0, the rest of the zeros are imaginary. So if I break this down, if I factor this anymore, I will see imaginary numbers. Therefore, this is the function as a product of linear, this one, and irreducible quadratic factors with real coefficients.